Hello, guys. Can we have your attention now? Hi. Okay.
Hi.
Get your attention.
Thank you, Dal. Uh, I hope the networking time was very successful, and I have a good news for you. If you stay till the end, we have the lightning talk with the beer and the pizza, and it's also a networking time, so you can talk with people you didn't finish to talk with, and you know when people are drunk, they say more things. So if you didn't get an answer, maybe you should stay. You'll get it later. The next presenter is, I'm lucky today, he's one of my friends. He's PhD student, third year from NIST, Nara Institute of Science and Technology. He graduated his master in only 1 year. That's why he's my senpai now, because I had to do 2 years. Yeah. So he did a research in Germany and in Japan, and he would like to share with us what he learned. Thank you, Matsuda-san.
Hi. Hello. Thank you. 聞こえてます? Thank you, Conan. So today I'd like to talk about the EmoTour. That it is a work in Germany. I stayed in Germany for 1 year, and I do this research. I'd like to talk about this. So my name is Yuki Matsuda. Come from Nara Institute of Science and Technology, the same laboratory is Conan. So I'm PhD student, third year. So I should write the dissertation, but not finished yet. Yeah, 頑張ります。Yes, and my research topic is the mobile computing and participatory sensing, smart city, or civic tech, something like that. And today I talk about the research with Ulm University in Germany and Itomo University Russia and NIST Japan. So today's topic is travel. So I want to ask everyone, do you like the travel? Yeah. Thank you very much. So I love the travel. So during my stay in Germany, so I visit the 9 countries and 24 cities in 24 days. Yeah, it's very intensity. Yeah. So maybe I cannot do after graduate. so I did. Yeah. So I did before graduate. Yeah, from German, and I go around and like this. Yeah. So and I want to ask about also how to when will you go to the sightseeing? How do you make a plan to where will you go and something like that? So maybe many people use the TripAdvisor or Google Maps or another common services. But so I feel the problem that these services. So one of the problem is so there is a many place or the candidates to visit, but there is a many so this is a kissing peak, but this is not included in the TripAdvisor. So this is just a Google Map thing, but this is not included to the TripAdvisor. Also, this building is very historical building, but it's also not included in introduced in TripAdvisor. So I mean that there is many missing places. So because it depends on the user review or user post. So yep. So it is a problem. And also, I visit Amsterdam. So I checked the TripAdvisor, and everything is 4.5 ratings. So but the Anne Frank house is a maybe not happy place, I guess. But the Van Gogh Museum is a very amazing picture. I can see the picture, and another place is very calm place. So I want to know why this place got the 4.5 ratings. So I mean this emotion is one of the reason why this place got this ratings. So my motivation is I want to know the tourist emotion during sightseeing. So to make an emotion-aware tourist guidance system, so I'm working on the tourist emotion recognition. So I named this EmoTour. And so from now I talk about the research theme. So I want to know the tourists go around the city and feel happy or not good feeling or something like that. And finally they feel happy or disappointed or unsatisfied. So I want to know that this user feel which feeling using the sensing technology. My approach is I focused on the unconscious actions of tourists during the sightseeing. So because the usually tourists behave when look something, they stop with this seat or look some device, some object. But if the user don't feel happy or don't feel interesting, so they look his smartphone and go through in front of the object, something like that. So I focused on the unconscious behavior of tourists. So especially I focused on the five modalities. One is eye movement, and second one is body movement, and last one is head movement, and also audio and videos. So for example, the gaze at something or lost his way, or use a voice assistant or guidance system, or take a selfie movie or photos. So the hypothesis is there are links between the emotion and these actions. So this is a workflow of my research. It's can be divided with 3 steps. The first one is we divide the whole tour into the very small part of the tourist site. It includes some at least one sightseeing spot, and I want to know the emotion for each sessions. And during session, they wear some wearable devices, and they also have a smartphone, and they go sightseeing freely. And at the end of the session, they take some short movie about for example, to send my friends now current feeling. So here is very nice place, or here is very awful place. I don't want to come again, or something like that. And finally, we asked labeling. This only for the research. And finally, we collect every data collected by the wearable device or smartphone, and combine with the labels and build emotion recognition models. Yeah, so this is a actual device. Yeah, so one is a pupil, is a eye tracking device, and also I put the head movement. That is 9-axis inertial sensor, and also use a smartphone. And as a label, we collect the 9 emotion status, excited, happy, relaxed, sleepy, or bored, and something. And so then we have the many data and labels, and we build emotion recognition models using this scheme. At first we should derive the features from raw data. So for the eyes gaze, so we calculate the phi and eye movement, the looking up, looking left, looking right, or something like that, and calculate the percentage time for looking up and down, and left and right, and average or standard deviation of the phi and theta. And for head movement and body movement, we calculate the count of looking up and down when move the head, and as a body movement, we count the step of the foot count of the foot step by using accelerometer and gyroscope. And for the audio data, we extract the 65 low-level descriptors. It's called LLDs. So using OpenSmile, it's the open source software, and also derive the first-order derivatives. And for visual data, we extract the facial action units. It means the bow is upping, or the, how can I say, ここわかんないですけど, the mouse is up or down, or the, ここわかんないですけど、なんていうかわかんないですけど, here is the narrow or something like that. sorry, I cannot explain well. But yeah, so like this. And we have 45 features. It's also extracted by OpenFace. It's a open source software. And after that, we have the features, 4 features, and we make some emotion recognition models to make predictions, and also calculate the min-max mean. And finally, we built the emotion recognition model by using the labels and features. And as an experimental field, we select the Ulm, Germany, and Nara, Japan. It have completely different place, have a completely different characteristic in this place, and like this. And also my professor also helped me. Yeah, and they take a selfie movie. And sometimes the general people ask me, what are you doing now? and yeah, so many German guys feel you are very strange guy. So they ask many times. And finally, this is a result of emotion recognition task. So we divide. So unfortunately, we don't have not so much data. So we divide the positive emotion and negative emotion and neutral emotion, and we can estimate the 71% recall score of the 3-class emotion recognition task. Okay. So this is my current result, and I'm doing now also, and yeah. So and finally, so I want to use this system to make an emotion-aware tourist guidance system. So for example, some guidance system provide some guidance information to user, and after sightseeing, the user feel satisfied or not, and we collect this feedback to the guidance system and make a satisfaction model when some guidance information make user good feeling or not, and update the guidance information, and I want to eliminate the unsatisfied situation. So this is my that's all my presentation. Thank you for listening.
Thank you very much, Matsuda-san. I understand now why you are my senpai. So we have like 10 minutes for questions. Are you ready? Okay. Okay, thank you.
Thank you so much for your presentation. I think it's really cool, like what you are doing. So I have a question about human biasness. So during your experiment, do you consider biasness of the human nature? Because I do a lot of experiments, and sometimes in my experiment, like driving experiment, I notice that people tend to behave differently when I tell them we are going for experiment. So they ask me, how should I drive? And things like that. So their feeling kind of changes, or their behavior, they tend to be stiff. And so what I do in this kind of situation, I try to talk to them and like relax, and they don't even know when we start the experiment. So like my question is, like during your experiment, sometimes someone might just decide, oh, maybe he needs this, and then he will go to the place and take a photo. But actually inside the person's heart, he doesn't think that this place is cool. So do you kind of consider these kind of things in your experiment?
Okay, thank you. So actually we don't have not so much data now, so I cannot consider about the personal, the human individual features. So, but now I'm trying to know the cultural difference between so we have 10 Russian people and 8 Japanese or something like that. So I'm now writing the paper. so now the score is not good, but between the Japanese and Russian, it becomes there is a big difference between the Japanese and Russian. So you can see for Russian, the behavioral cues, the head movement and body movement is very nice feature to know the emotion, but the audio-visual data is not so good because maybe they don't express on the face or voice for the Russian, but Japanese is quite okay. Yeah, something like that. But I want to know. So I should consider about your question also after get more data. Thank you for the question.
Thanks for the great talk. I know you talked about you use some open source software for the analysis. Can you talk a little bit more about if there is machine learning and data that was previously fed into the model to do the analysis?
This one?
Well, that, and I think you said there was like maybe it was open Open Smile, maybe, yeah.
So we just use this open source software to extract the features, but and this part is not my part. So I'm working with the Russian guy from St. Pete's Itomo University. But yeah, so this is a very so I can describe detail, but so we just use this software to extract, not touch inside of this software.
That's a machine learning.
Yes, basically.
Okay.
And OpenFace also use the machine learning. So I can talk about this. So at first they extract the face area, and detect the eye position or something like that, and extract crop the images and calculate the relationship between the mouth and bow and eyes and nose or something like that. So it's also a bit based on the machine learning technique.
Okay, again, thank you for the wonderful presentation. I just have one question. Considering your data collection, it seems like you're using a control group where they have this device on them, and maybe having these devices present kind of changes their reaction. So I know that, of course, there are different programs or methods for collecting facial recognition data, maybe from a camera that's set at a higher point that can actually get a higher resolution image of a face or something along those lines. Have you considered that sort of data collection as well?
Yes, so actually the participants always say it's very uncomfortable to sightseeing, and also many people looking at me. So it's not natural situation, but maybe in future for example the Google Glass can detect the eye movement, or already Jin's meme already detect the eye movement, so more naturally. So why I use this device, because it is more accurate for the research. Yeah. So, but this is not useful actual situation. I think so. So I should consider the more natural condition.
Yeah, I think we have time for. It's okay. One, 2 questions. If somebody wants to ask something, okay.
First of all, thank you very much. It's a very nice idea. I would like to know when you started this research, I'm sure you must have done some prior art search. So I want to know, like, what is the closest prior art like in the market now?
So you mean the previous research?
Yeah, something which is very close or similar to what you have done in the market. Yeah.
Maybe no.
So there is no such thing. So
yeah. So
it's great.
Some study working on the visual processing or speech processing in the laboratory condition, but not so much research focused on the tourist or outdoor place.
Okay, so the closest was TripAdvisor then.
Yeah, like that.
Okay, thank you very much.
Thank you for your presentation. My question is related to one of the sensors you are using with the camera. You said like this sensor has 9 degrees of freedom or something like that, so I want you to elaborate on that.
Sorry?
If possible. There was a sensor in the glass.
So this one?
Yes. So you said the sensor have 9 degrees of freedom?
3 axis accelerometer and gyroscope and magnetic field sensor. It's okay? No?
Yes. So I mean, this one is not 9. So
the 3 axis and 3 axis and 3 axis, and totally 9 axis.
Oh, okay. Okay, I got it now. Okay. Thank you very much.
What
Sorry?
glass is it?
No, it's not Jin's meme. It's a pew-pew. So it have 3 cameras. It's detect tracking the eye, left eye and right eye, and the world camera. So and Jin's meme only use the, I don't know how to say, the electricity.
Yes, I think I see my controller. It's okay? Okay, I think we need to stop here. But as I remember, there's a networking time again after, so you can talk to him directly. Thank you, Matsuda-san.
Thank you very much.
So we have 10-minute break. Then the next one will be the last speaker of today, and it's Adrien. and he will talk about machine learning for small data. Is this accurate? Okay, so Adrian is already here, so we will start from 4. Thank you.